So today we're going to justify if a triangle is congruent using side, 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 angle, side, angle, 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 or hypotenuse, leg. So let's go through the methods for proving triangles are congruent. So the first method is side, side, side. If all three sets of corresponding sides are congruent, then the two triangles are congruent. So for example, if we have two triangles, so let's say our triangles are A, B, C, and D, E, and F. If we have three sets of congruent sides marked, then those triangles would be congruent by angle or side, side, side. So we could say triangle ABC is congruent to triangle DEF by side, side, side. The next way to prove that triangles are congruent is side, angle, side. So in this case, if two sets of corresponding sides and their included angles are congruent, then the triangles are congruent. This is an important phrase here, included angles. So this means that the angles must be touching both sides. So for example, if we have two triangles again, so I have triangle A, B, C again, and D, E, F, we might say that AB is congruent to DE, AC is congruent to DF, and then A and D are congruent angles. So notice that the angle is touching both of those sides. So we would have triangle ABC is congruent to triangle DEF by side, angle, side. The next method is angle, side, angle. So an angle, side, angle, we have two sets of corresponding angles and their included sides are congruent for the triangles to be congruent. So when I draw my two triangles again, ABC and DEF, this time I have two sets of congruent angles. So B and E are congruent, C and F are congruent, and I need the included side. So the included side is the side that's touching both angles, BC and EF. So then we could say that triangle ABC is congruent to triangle DEF by angle, side, angle. The fourth method is angle, angle, side. So an angle, angle, side, if two sets of corresponding angles and a set of sides outside those two angles are congruent. This is a non-included side then, and those are congruent, then the triangles are congruent. So if I have triangle ABC, and I have triangle D, E, and F, when I look at those two triangles, I could say that A is congruent to D, C is congruent to F, and AB is congruent to DE. So the side is only going to touch one of the angles instead of both this time. So in this case, triangle ABC is congruent to triangle DEF by angle, angle, side. The last method is hypotenuse leg. So in hypotenuse leg, it's important that it's only right triangles. So if the hypotenuse leg and if the hypotenuse and corresponding legs of two right triangles are congruent, then the triangles are congruent. So these have to be right triangles. So we could have A, B, C, D, E, F. So we already have our right angles. We're going to say that the hypotenuses are congruent and one of the legs are congruent. So then we could say that ABC is congruent to DEF by hypotenuse leg. If it is not a right angle, you can't use hypotenuse leg. So let's just review two important topics which come to play when we're trying to choose our method. So an included angle, remember an included angle is an angle that is formed by both sides. So if I have the sides PI and PG, my angle is in between those, which would be angle P. If I have PI and IG, the angle inside is angle I. And if I have PG and IG, the angle formed by those would be angle G. An included side then is a side that touches both angles. So in this case, if I have angle P and angle G, the side touching both of them is PG. If I have angle I and angle G, the side touching both of those is angle IG. Or, sorry, that'd be the last one over here. And if I have the angles I and P, the side being touched by both angles is PI. One last important thing to know is reflexive property. So a reflexive property means that something is congruent to itself. So this happens when there's a shared side. So for example, in this picture, if I have A, B, C, and D, we could say that that shared middle side, BD, is congruent to itself, which will help us with proofs and will help us determine methods for when triangles are congruent. So what method, if any, can be used to prove that triangles are congruent? Remember that you need 3 pieces of information in order to prove that the triangles are congruent. So in number 1 right now, we have one set of sides that's congruent. We have 2 sets of sides that are congruent. And we also know that this shared side CD is congruent to itself by the reflexive property. So now we have 3 sets of congruent sides. So the method that we're using to prove the triangles are congruent would be side, side, side. So we would have triangle CAR is congruent to CSR. Remember that order is important, so you have to pay attention to what things are congruent. So if CA is the side with the circle, and it's the first 2 letters, then the other side of the circle has to be the first 2 letters. Number 2, so if we have one right angle, remember that there's also a right angle on the other side of our triangle, which means we right now have one set of congruent sides, we have one set of angles that are congruent, and we also have a shared side again, which means that that is congruent to itself. So now that I have 3 pieces of information, I have 2 sides and an angle. Our method in this case would be side, angle, side, because we have our sides and we have the angle touching both sides, so it's the included angle. So in this case, triangle GOF is congruent to LOF. If O and F are the shared side, they have to be the last 2 letters in the name of the triangle. Number 3, so in a bow tie problem, you always have vertical angles. So if this is a right angle, this is another right angle. So in this case, I have right angles that are congruent. I have one side that's congruent to another side, and then I have another set of sides. Now we have to be careful here because I have 2 sets of sides, but this is not a side angle side problem because the angle is not between the 2 sides. So instead, my only other option would be hypotenuse leg, because side side angle is not a method to prove that triangles are congruent. So this has to be hypotenuse leg because it has a right angle. Otherwise, we couldn't prove the triangles were congruent. And then we have triangle DNA is congruent to triangle CNE. Number 4, all we have is that one side is congruent to one side. Side 2 is congruent to side 2. There's no other conclusion I can make about these triangles because they don't have vertical angles or shared sides. So because there's only 2 pieces of information, the method would be none. There's not enough information, so we can't actually prove the triangles are congruent. In number 5, we again have another right angle. So far we have angle and we have another angle. We also know that we have a shared side, so that side AE has to be congruent to itself, which gives us our side. So in this case, we have 2 angles and one side that are congruent, and the side is between both angles, so it's an included side. So the method that we would be using is angle side angle, and we would say that triangle CAE is congruent to triangle KAE. Number 6. In number 6 right now we have one set of angles that are congruent, two sets of angles that are congruent, and they have a shared side, MT, which is congruent to itself. So now we have two angles and a side. This time, the side is not included between the angles, so the method we'd have to be using is angle, angle, side. And then we would have triangle MHT is congruent to triangle MAT. Number 7. So in number 7, we have two right angles that are congruent. We have two sides that are congruent. And we also have a second set of sides that are congruent because of the reflexive properties. So now I have two sides and an angle. The angle is not included. Remember, I can't use a side angle or side angle. I can't have an angle that's not included. So my other option is HL, and because it's right angles, we can use the method HL. And we would say that triangle I, because F had the right angle before, now I has the right angle. So we would have triangle I, P, F. Remember that the I and the F are representing different angles in the triangles, so they don't need to be in the same place. In number 8, I have vertical angles. So since I have vertical angles, my angles are between the two sides because I have a set of sides here, a set of sides here, and my angles, and the angle is included. So in this case, our method would be side angle side, and we would say that triangle DRI is congruent to VEI. In number 9, I know that I have reflexive properties, so JM is congruent to JM, so I have one set of sides, two sets of sides, and one set of angles. The problem here is that the angles are not included in the sides, and they are not right angles, so I actually can't prove that the triangles are congruent yet. I would need more information. So right now my method would be none, and I can't write a congruency statement because I don't have enough information.